Hi, this is Dr. Green. We are working on WebAssign Homework 8 and an example for problem number 16. So we have a social psychologist here who's measured social well-being in a sample of 12 adopted children before and following adoption. So here is the data. So those are differences in before and after scores. So notice here that differences were already computed, and it's the same way in your problem. In another setting, you might have to compute those differences. So what we want to do is we want to use the normal approximation here to the Wilcoxon signed ranks t-test. Okay, and to do that, we follow these steps. We're going to compute the differences, already done. Going to rank each difference, and it's regardless of sign. With the lowest difference being ranked as a 1. And then we're going to separate them into two groups, the positive differences and the negative differences. Sum each group, compute a z-score for your test statistic, which is the smaller sum of ranks. And then our rejection is if your z-score is less than negative 1.96 or greater than positive 1.96, with this being your mean and standard deviation. So these are given. And n is your sample size. And then this is your formula for z-score. So let's go ahead and work through problem here. So what I did was first I have to rank these differences from smallest to largest without regard to sign. Okay, so these are ranks regardless of sign. So these are the ranked differences. So if I'm just looking at the number and not looking at the sign, then 1 is the smallest number in the list, and then 5, 6, 8, 9, 10, 12, 14, 16, 22, and 24. Now you do want to keep the signs attached because over here we have to separate the positive and negative ranks. And then your rank, the smallest number is the 1 without the sign. Going up to the largest number is the 24, and that's rank 12. So now we want to separate these to positive and negative ranks. So the ranks that belonged with positive numbers are the 3, 6, 7, 8, 9, 10, 11, and 12. So 3, 6, 7, 8, 9, 10, 11, and 12. And those sum of those ranks is 66. And then the negative ranks, so those are the ranks that go with the negative numbers, 1, 2, 4, and 5. So it's really important to rank these in order without paying attention to the sign. And then the sum here is 12. And the smaller of those two numbers is 12, and that's your test statistic, capital T. So now we can do the normal approximation. So our capital T is 12. N is the total number of samples, which for us was also 12. And then we figure our mean and standard deviation. These are the formulas below. So this is going to be 12 times 12 plus 1 divided by 4. So 12 times 13 divided by 4. Which is 39. And then this will be square root of 12. And then 12 plus 1 here is 13. And then 2 times 12 is 24, plus 1 is 25. And then we're dividing down here by 24. And if you compute that in the calculator, you get 12.747. So now we're ready to compute the z-score of our test statistics. So the 12 is our t. Minus this mean is 39. And then our standard deviation down there was the 12.747. And if you compute this in the calculator, you get negative 2.12. So that's our z-score. That's the first thing that they asked for in WebAssign right here, negative 2.12. And then they want to know, are we going to retain or reject the null? And negative 2.12 here is less than negative 1.96. Remember, plus and minus 1.96 are the cutoffs here. So if z is less than negative 1.96 or greater than positive 1.96, we reject the null. So we are going to reject the null here. And that's this option. And finished.